I mean, look, there's a chart, and it's like 0 torr here, and then it's got a curve saying what the efficiency of the pump is as you get down to lower and lower pressures or higher pressures. It'll go up to 30 psi. It's a nice pump, but they pulsate. Plus, if you don't have a reservoir vacuum, then you have to pump down the lines. So what I want to have is a vacuum reservoir on here. In cars, the vacuum reservoir, I don't know whether they still are, is a sphere. Like it's a plastic sphere about that big. I don't know what they look like now. I've seen some that were tin cans. They look like a big, like a tall coffee can, but they're not open on either end, and they're painted black, and they have a fitting on them. So I would like to have a vacuum reservoir on here, and it's okay because it doesn't weigh anything. Attaching this to that is going to be a bit of a problem because there's really no place to attach it on the bearings. I'm going to have to make a platform above the bearings. If you look at it, you'll see what I mean, to support this. I used this U-channel because I found this at a surplus place in Wheeling, Illinois, and it's really, really stiff. I don't know. I mean, it must be like some really nice alloy and some really nice tempering of aluminum. It's extremely stiff. It's I mean, for something this thin, it's a pretty nice piece of metal. It's the right size, and because it's thin, it's lightweight. I also have these surfaces along here, so that I have a lot of options about how to attach to that, and I can even come in from the back side if I want. So this was my first foray out mounting little tiny metric screws. So the thing that most people run up against when they go to use a motor is always mounting the motor. If they have their own invention, the first thing that's like, how do I make this thing spin around? Well, I have the motor. How do you make the motor sit still? You always have to make a motor bracket. You always have to make a mounting plate of some kind or mounting area on your device. So I made these mounting brackets out of bent brass sheet, and they're number 2 or metric size 2 screws. So I do all my layout by hand. So this is a pretty fine layout job. So that's how that went. This pulley right here, I cut on the metal lathe, and what makes it slide, because it has to slide back and forth. So this has to rotate. It has to make the thing rotate on this motor, but this goes up and down, so this has to pass through here. So it has to be able to turn it like that without offering any vertical resistance. So this is a spline joint. It's a four-face spline, and this mechanism right here, actually, if you turn this upside down so that the load are on this end, this is what is at the bottom of a drilling rig. If you ever look at a construction site where they're drilling foundations, this is the part that's on the bottom of the machine. The up and down part is a cable crane hoist, but then at the bottom there's an apparatus like this that's turned by a hydraulic motor, and that's what rotates the drill bit. Naturally, as the drill drills, the drive shaft has to be able to drop in the hole, and this is the mechanism they use. So to make the hole square, I cut this on the outside. I got the diameter the way I wanted it, and then I cut the inside. I drilled the inside as close as I could to the square brass, and then I got a really good fit, and I pressed the brass in there. And then inside of the brass, there's a round piece of tubing that's soldered on the inside, and it actually fits by design, the people who make the brass make the round stuff fit in the square stuff precisely. It's why they sell the stuff. It's why you pay money for it, is because there's all these different fits that happen between these different sizes of material. So there's a round piece that's soldered inside the square one, and the round piece is actually the bearing surface that goes through. And on this one it's soldered. It's actually soldered to the vertical shaft.